Hello and welcome to Mathssteps. Today we are going to learn how to write in standard form and ordinary form. Let's have a look at this example. As you see, we have here a large number, and that's the reason why you use standard form, to be able to write large numbers in a most effective way and to be able to compare them correctly. So not just for the very large numbers, but for the very small numbers as well. The numbers that have many zeros after the decimal point, just to make it easier for us to handle in problem solving. So how are you going to change this number to standard form? Remember something, that the number in front of the standard form, so this is the general form of a standard form, okay? A here should be bigger than 1 and smaller than 10, always. So a number bigger than 1, smaller than 10 here is going to be 1.996 times. Now, remember, any zero, any 10 to the power of something, so any indices represent 8 times 10. So let's have a look how many times 10 we are going to add. So how many zeros we're going to add to the power. So times 10 to the power of, let's have a look. So we place the decimal point here. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the power of 8. There you go, just like that. So keep counting after the decimal point where you place. The next one is going to be this number, is 93 millions. How are you going to write this as a standard form? So we place the decimal point here. So it's going to be 9.3 times 10 to the power, let's have a look, 1, 2, 3, 4, 5, 6, 7 times 10 to the power of 7. Next example, we are going to convert from standard form to ordinary form now. So this one is going to look like this. So it's going to be, let's place the number as it is, 2.6. And we're going to need 9, so times to the power, times 10 to the power of 9. So 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, stop here, and then now replace this, or under all these arcs that we've created, you put a 0 under. So 1, and this is what the number is going to look. So remember, count from the decimal point and to the right. So this is our new number. So in total, they're going to be 1, 2, 3, 4, 5, 6, 7, 8 zeros. And so the new number, it is going to be this one here. So 2,600,000,000. So it's a very large number. Another method that I want to teach you is that, so if you find hard counting after decimal point, you can go for creating the whole number first. So from 2.6 to times 10 to the power of 9, we can change this to 26. Okay, 26 times 10 to the power of 8. All right, if this is a lot easier for you to remember. So 26 times 8 to the power of 8. And then now you can simply add another 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. So then, of course, our number, it is exactly just like this number. So where did you find the 26 from? Because 10 to the power of 9, we can write this as 10 to the power of 1 times 10 to the power of 8. All right, and then multiply 2.6 times 10. That makes 26. So 26 times 10 to the power of 8. And then change this to the whole ordinary number. Remember, this is not a standard form. This is just a form that we created to make it easy for us to change or to convert from the standard form to a normal ordinary form. Let's have a look at another example. Again, here you can go for, so rewrite the number as it is. This is the strategy. One, you need 7 digits all in total after the decimal point. So there's 1 already there. 2, 3, 4, 5, 6, 7. And replace this with numbers, with the zeros to hold the place value. There we go. And so this is our new number. Actually, it is 81 million, and cross out the decimal point, all right? 81,900,000. Or method number 2 would be to create the whole number here. So 819 times 10 to the power of 5, because 10 to the power of 7 is going to be the same as 10 to the power of 2 times 10 to the power of 5. All right, so 2 plus 5, 7. There you go. Why did you split it like this? So we can, 10 to the power of 2 actually is 100, so I can change 8.19 to 819. So I need 100 to multiply this by 100. And then now, can you see now? We have a whole number here and 10 to the power of 5 here. Simply add another 5 zeros, 2, 3, 4, 5. There you go. The answer, of course, is going to be the same. So you can follow this method, rewrite the number as it is, and count from the decimal point, count 7 place values to the right, and then replace, put a 0 to hold the place values under each arc that you create. Or this method here, by creating the whole number first, or making the whole number first, and then adding the rest of the zeros to hold the place value. Now, what about now? So here is another number, it's a very small number. We are going to change this to standard form. Again, we need to make the number that is smaller than 10 and bigger than 0. So this is where I'm going to place the new decimal point. And now I count from the new decimal point to the left. So 1, 2, 3, 4, 5, 6, and I stop here, right? 6. Now, my answer is going to be 2.2 times 10 to the power of minus 6 in this case, minus 6, because this is the number is smaller than 0. As you see, it is smaller. Then it's a very small number, so it's to the power of minus 6. If you have to write this as a fraction, for example, this number would be 22 divided by 10 to the power of 7, or 2.2 divided by 10 to the power of 2.2 divided by 10 to the power of 6. See? So 10 to the power of 6 stands in the denominator, and this will be changed as 2.2 times 10 to the power of minus 6. Okay? To the power of minus 6. This is how you change. And then the next number, it is going to be, there you go. Okay, this is the next number, and we place the 0 right there between both threes, because you need 3.3, the number smaller than 10, bigger than 1. Then you start counting from the new decimal point to the left. So how many zeros there are altogether? How many digits? And so there are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so our answer is going to be 3.3 times 10 to the power of minus 10. So let's have a look again. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3.3 times 10 to the power of minus 10. There it is, 3.3 times 10 to the power of minus 10. But how about this number here? 7.3 times 10 to the power of minus 3. This is how we change this to ordinary numbers. So you have 7.3, This is times 10 to the power of minus 3. So we start again counting from the decimal point to the left this time. So we have 1, 2, 3. Okay, then you replace the arcs with the new zeros, place the decimal point, new decimal point, and there you go. So our new number is going to look like this, 0.0073. Next one, there you go. So anytime you make an arc, you put a 0. And now here, what I've done here, I have created a table for every single exercise that I just taught you, so that you remember how to change ordinary numbers to standard form, so very large numbers. And here, from standard form to ordinary numbers. Here we have small numbers, ordinary numbers. We're going to change them to standard form. And the same thing, vice versa. We're going to change standard form to ordinary numbers. So numbers are very small. So let's have a look at the first one. So it is a very large number. So this is where we place the new decimal point, okay, because the number should be smaller than 10. And then let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our number is going to be 9.753. So never leave the other digits behind. 9.753 times 10 to the power of 11. Next one. This is where the decimal point should be. So 7.02. Now let's count after decimal point. 1, 2, 3, 4, 5, 6, 7, 8. Our answer is going to be 7.02. Okay, times 10 to the power of 8. Now, let's work with very small numbers. So the decimal point is going to be right there. So it's going to be 9 times. So 9.0, but we can write it as 9 times 10 to the power of, let's find out now. So this is where we start counting. 1, 2, 3, 4, 5, and stop. So we have 9 times 10 to the power of minus 5 now, okay? Minus 5. Next one, this is where we place the decimal point. We count from the decimal point to the left. So we have 1, 2, 3, 4, 5, 6, 7, and stop here. So our answer is going to be 1.7 times 10 to the power of minus 7. So 1, 2, 3, 4, 5, 6, 7 to the power of minus 7. Okay, let's change this one from standard form, as you see, to ordinary numbers. So let's write the number as it is, 1.24. And now 5, you need 5 multiplied by, you need 5 digits after these decimal points. So 1, 2, 3, 4, 5, and stop. Now replace those with zeros. And our new number, so remove the decimal point, the new number is going to look like this, 124,000, so 124,000. Okay, and this number again, rewrite the first number 2.009 as it is. This one says times 10 to the power of 6, so we're going to need 6 digits after decimal point, so we start counting 1, 2, 3, 4, 5, 6, and then place a 0 under each arc we make. You can rewrite the number again, 2,009,000. So this is our number, 2,009,000. To change from standard form to ordinary numbers, when you deal with very small numbers, this is what happens. 1.24 times 10 to the power of minus 3. So write the number here a bit, so leave a little bit of space, because this is going to be a number with many digits after the decimal point. So write this here, so 1.24, and I start counting from the decimal point to the left. So we need 3 digits. So 1, 2, 3. So 0, 0, place the new decimal point, and then rub the old decimal point out and rewrite the number again, 0, 1, 2, 4, 00124. This is our new number. And the last one. So rewrite A as it is, but leave space in front of the number. So 2.009 times 10 to the power of minus 4. So you need 4 digits in front of the old decimal number. So this is 1, 2, 3, 4, 0, 0, 0. This is where the new decimal point should be, 0. So the new number is 0.1, 2, 3 zeros, okay, 2009. So 0.0002009. All right. It might sound a bit complicated, but once you get the hang of it, the conversion becomes a lot easier. And here there's something for you to work independently. The first one you have to change in standard form. You have 2 large numbers and 2 small numbers, very small numbers and very large numbers. And here, do you think this is a standard form? Remember what we said about A? Should A be a number bigger than 10? And here we got to change to correct standard form, because can you see A here? Should A be smaller than 1? So have a think. Thank you very much for watching Mathssteps. Have a lovely day. Bye-bye.